Hi guys, how are you?
Hello.
Hi. So we have the digital Bacillaria results that we want to. I'm trying to write a paper on it, so I was talking to Dr. Gordon, and he was asking me how it's coming, and I get it. It's coming along, I think. Um, but we need to point out some, like we need to show the results and the rest of the methods. So you guys said you had some results written up, or you had some graphs to share. So does anyone want to start first, or?
So we will share the result over Slack. I guess right now we don't have our laptops in front of us, but we will surely share results
Okay.
over Slack. We have defined the mathematics like what we are doing,
All right.
and we will share it over Slack.
Okay. So you define the mathematics. I have some of it, but like there's probably more like the for finding the shapes, like the shape of the cells. I don't know, and then like the motion or like the analysis between frames. So
Oh yes, so like we don't have defined like so much detailed math, but we are trying to figure out like how we can judge the motion of worm, and we are working on it. We will share like whatever we have done with
okay,
you and see like if it can be used.
okay. What about the graphs, like um, for the different results? Do you have the first of all? Do you have the training data? I'm looking through the repository. So what's in the repository on GitHub? Let's see if I can share the repository. We have Python code, thresholding, training models. Oh, we have manuscript, main document. I don't have anything in there yet. But yeah, I mean, so what in terms of where like you had the training data and then you had the output. So where is all of that?
Oh, so as far as now we have pushed, I guess, the label data that we have done,
Okay.
and it is like present there on something called testing images, something like that.
All
I
right.
will let you know. It's all a bunch of like XML files.
Yeah. Oh, here's the README actually. Okay, it has XML files. Then if I go into an XML file,
It has some labels like area and their positions.
okay. Yeah. Yeah. This is the bounding box, the definition of the bounding box. Okay. So if I go to the XML, then we have bounding boxes for each cell in the frame, I guess. So each of these XML files are different frames for different frames. So zero is what's the naming convention on the XML files? Do you know?
So actually, like these are the XML files which we have used like as a hand label data to train our model so that we can get the results. So we have like almost around
The
80 images.
the XML files are like the labels of the XML files are basically the frames folder that we had, the specific frames that we use for labeling, like sort of the numbers represent the frame number of that particular video. And like I want to ask like regarding the paper, what exactly do we do you require for like from like for regarding this project, like what all do we need to make a finished up thing out of it? Like we have one thing is, I guess, the data and like the deep learning methods, and so what's that that is required like to finish this, and what's the deadline for this?
Well, we're working towards I don't really know what the Dr. Gordon wanted to have a lot of it together by today, but it's that's like a just to kind of get everything together. But I don't know what the next step is to like really kind of get everything polished, and that'll be like during the fall. So I'm not really sure like what you didn't give me a hard deadline on this, but um, let's see. So I guess what we want for results is I'm not really sure how people are reporting them, but um, if you so you've trained the model and then now do you have testing data? What are you using for that? Or is it just the training part? I mean, I don't know how far you get.
So we are using like TensorFlow methods of deep lab to get the testing data sorted out.
Okay. And so what does it give you as an output?
So the image which we have showed is one of the outputs which we got. We will upload like we can run this model on the data set and see, like we will upload few more results like that on the GitHub soon.
Okay, yeah, because I didn't know exactly using the method that you're using what the output is. Because I know that like sometimes they give statistics, performance statistics, but that's not really useful. It might be that we could well we have the we I guess we have does it output images at all, or is it like I don't know how I don't know because I wanted to map this to an image, but it's something that I might have to do by hand.
So yes, they are output images like one we have shared and we already have in the doc.
Okay.
This is one of the output image, and moreover that like we will if we need more of some like that, so I will pick up the different frames like which look very different from each other and see like if it is working. We will upload it on GitHub.
Yeah, so I think like one way to do report it is to have like show an example image of like one example image, and then if there's like some that look very different, to give like just basically give example images and like give me a little bit of description about what they are, like what they represent, like I don't know, maybe like some of the parameters you use too. If you're setting it up with specific parameters, that would be good information to have for the paper. Um, I don't know if we need to build tables to report anything, and I don't think so. But just to have like some output and just to show like examples of, you know, different results. So if you have things that are different, then, um, we could do that as well. Does it also output like tabular data, like a CSV file?
No, so like data is just the like outline image which whatever it detects, it shows us. So like we can if we want, I think like oh, we can guess about tabular data, but I don't think no. The dataset doesn't provide us any kind of tabular data. It just provided with the image which has the labeled whatever we want to be labeled. Like if we have trained our model for Bacillaria in single cell, so it shows us that in this way.
Okay.
So
Okay, that's fine. Let's see. So yeah, maybe I don't know how many images that are outputted in a run, but if you could put all those on in the GitHub repository, let's see. So we have labeled data set, And then we could create a folder called output, which is, I'm going to create it now. And then we could put all the images in this folder. So let me get a link to it. I'll put it in the chat window. Or in the... Okay, yeah, I can do that, and then I can put it in, like, to the Slack later. But if we could just put all the images in there, and then maybe the particularly interesting ones, just send them on Slack with a little bit of a description of what it is. I saw that one, it was like a graph that compared two different... I don't remember where it was in the Slack channel. But that looked interesting, but I don't know what that represents necessarily. So
it's actually that graph represents like Dr. Richard Gordon has asked us to like see if we can somehow find like number of frame versus boxes which are detected in it. So through that graph we have tried to show like first of all it is very random between the frames, but as we have optimized it we are trying to get a straight linear line so that we can get all the number of frames equal in each, all the number of box equal in each frame.
Okay. Okay, yeah. Thanks for that. So that's an optimization graph. So yeah, that's what I thought. I just didn't know exactly what the comparison was. Let's see, what else do we have here? Yeah, I mean, just also if you have any more additional methods, I got a lot of the methods from that one document you sent me, but you said you had some additional methods that you needed to update.
Also not additional methods, like we want to update these methods like with technicalities and maths behind them. Like till now there is only a very brief description like what we have done.
Okay.
But the procedural description, we want to add like what is the maths behind it, how the pixels are getting different, etc.
Okay, that sounds good. Yeah, could you send that to me? Just that description? And it doesn't have to be super refined. I can write it. I can put it in and rewrite it a little bit, because the way I'm putting it in the paper is, I've got like a introduction and then some like introduction to neural networks, and then the methods, and then the results, and then the like discussion. And the methods are, some of it is like just a description of how you did things. There's some mathematics in there, and then the results are going to be like, I guess, some graphs with some description, and then the discussion will just be like, what have we learned?
Okay, sir, I will send it over Slack. I'm go. Oh yeah, by tomorrow.
Okay, yeah, thank you. What else do we need? So we have the like the images. We'll upload those to GitHub. We'll pick specific examples and send them to me on Slack with a little bit of description of what it is. And then like a document with the methods, like just a walkthrough of things that you did, maybe like parameter settings if possible, if applicable. And then I think that's pretty much it. I mean, I don't know if we can make any, well, I can make graphs from some of the data in the training set too, but that's not necessarily critical right now.
So we can make like diagrams from the training set, I guess. Like if we are detecting someone to explain it more better, we can make diagrams for that.
Okay, yeah, that sounds good. What kind of diagrams are you thinking? Like images of the Bacillaria, or
Like so, we have seen some papers of different image or where image processing is done, they kind of show it through visual diagrams like what is done behind the layers and all. So we can think of it like as showing it as diagram.
Okay, that sounds good. Yeah. Yeah, I mean, in a lot of the, think of it like, if you've read a deep learning paper or a machine learning paper, how do they usually present the results? They might have some graphs. We talked about the tables, but that's optional. And just the way they present the data. That's a good way to, like, so if you wanted to make a diagram, you know, think about it like just go to a couple of machine learning papers and just look at like how they lay out the results, the kinds of things they report. Because I think more diagrams the better, really, because it's a hard thing for people to wrap their heads around. A lot of people, especially reading this paper, aren't really going to know the methods in detail. So, I mean, part of it is like we want to write it so that it's pretty accessible. So it's not, we don't have to get into deep technical details, but we do want to give some. And then we want to give like as much help to the reader as possible in terms of the, reporting data, but in a way that's not like, a graph where they can't understand what's going on in the graph. I mean, the one graph you sent me is fine. We'll just have to write like a legend for it that's, pretty understandable. Do you guys still have the link to the paper? I can't remember. It should be in one of the private Slack messages that I sent. Um,
Yeah, we have the doc.
okay, yeah, right here. So this is the doc from. Okay, yeah. So that doc, I've been working on it over time, and it's gonna continue to be added to. Um, yeah, and so I'll probably contact you on Slack off and on to see, if I need anything additional or if I have questions. So, and then, maybe we'll go over it again, maybe next week at this time, at the Friday meeting or a Friday meeting time to like go over it and actually walk through the paper. Because right now so I have the stuff you sent me on neural networks, and I have some of the methods in there. So okay, here it is. Let's open it up. Actually, let me share my screen for a minute. I might as well just go through it now. Okay. All right. So can you see my screen?
Yes, sir.
Okay. So this is the working title page. And then we go down through the document. And we have an abstract. I've yet to get that put in place. The introduction. So this is just the introduction here. We kind of get into like Bacillaria and why this project is important. Um, then I've got some figures of like Bacillaria images. Then I have research motivation. So that's why are we doing this? Then I have the description of neural networks. So I've trimmed it down somewhat from what you sent me, but it's still pretty. I think the way I've got it here is pretty like straightforward for this audience. We just walk through a neural network. And so people who maybe have never heard of it before can look at it and say, oh yeah, this is how it works. And then we get into methods, which are the measuring the Bacillaria. So there's a description of that, video extraction, noise reduction. So, there's some citations to add here. And then here's an image of the 5 points on the cell. and then some equations, the gradient equations. I put them into Google Docs using their equation editor. And then I redid your diagram like in a little bit different format. So you sent me this diagram and then, the description underneath. And then more description, methods, another diagram. Then we get into like the watershed and canny edge detection, which, I would report as like negative results. But that's like sort of, so the thing about a method section is that people will, sometimes it's important to report negative results because, people want to know what didn't work or what you tried. And so in this results, I'm going to feature those two things first and show the performance. And then I'm going to show the stuff from TensorFlow that you're going to provide me. And then I'm going to put it in the paper. And, that'll be it'll contrast the two. So, you have one where you might use a method that maybe is more familiar to biologists using ImageJ. Like biologists use ImageJ sometimes for, to segment images, but they don't really know a lot about it. But they may have heard of these algorithms. And so I wanted to show them that, even if you use these algorithms, they're not great. But if we use TensorFlow, we use deep learning, it's a lot better. And so that's what I'm trying to show here. And so we walk through these methods, and then we get to the results. And so again, we talk about watershed and canny edge. And then we go into the deep learning, and that's where we have these results, and that's yet to come. So that's where that will be. And then the discussion, which is this part here on, it's going to tie everything together. So we have the results, we have our aims, original aims, and they're going to be put in here. I've kind of put them in now. I need to expand it. And then just what that means for the future, what we've learned from the paper. And that'll be it. And then we have our references, of course. And, we'll put some more references in here. And so that'll be good. And then that'll be the paper. And it's just a matter of like, telling a story to the reader. So I think we're getting there with the results. We can get a couple more, good images, maybe contrasting images of different things. If there's some interesting results, if you want to alert me to that, I should showcase here. If there's something that's like really interesting, you thought was interesting, let me know, because I can write about it. I can put it in the results. Otherwise, we can just describe what we found, and I think that'll work. I think people will be interested in it and read the paper. That's what we want. Any questions? Okay. All right. So, anything else you want to talk about, or we missed?
So like we are aiming digital Bacillaria for a paper like in which conference?
Well, we're thinking about. I think Dr. Gordon's thinking about putting it into a book as a book chapter. But we don't have to do that. We can submit it to a conference or a journal just as well. If you have a preference, let me know. Because the book chapter will be, well, we talked about like the Bacillaria journals. And the problem with the Bacillaria specific journals is they don't understand this kind of work. I don't know. It's like in journals and sometimes in conferences, you'll find that like they have a specific set of things that they're interested in. And sometimes they're inflexible with regard to some new method. So it's going to be a little difficult to find the right place for it. Book chapter, because Dr. Gordon's the editor on this book chapter. That might be a logical venue. Well, we don't have to put it there. It depends on if we could find a better home for it. So if you have preferences or ideas, let me know on that.
No, sir, like book chapter is fine. We are just confirming.
Okay, yeah, and I like I said, I don't have a. I mean, you wanted to get things kind of in place by August 31st, which is tomorrow. So we kind of have things in place now, and I think if we just keep working on it and just say the deadline is as soon as we can get it together, that might, because I don't know what the actual deadline is for the book chapter, but um, we don't want to. What happens when you have open-ended deadlines too is that you end up delaying it and then it doesn't happen. So you know, well, we'll work on it, and we'll just keep communicating with me.
So, like, we will try to work tomorrow full day on this only, and we will try to get as much as we can.
Sure. Okay. That sounds good. So yeah, if you have any other questions, let me know in Slack and send me the materials in Slack, or post the images to GitHub. The stuff that you're getting out as data. I think what we'll do is we'll cite that in the paper. Like we'll say, we have the full results on GitHub. They're hosted there, but we'll showcase some here. So if people want to go and see the full results, they can go to this repository and look through them. And then we can organize it in different ways, or we can put it in the README that these images, give them a little bit more detail. But to have that's the paper we did last year. Actually, we did it like that, where we had put a lot of it. We took a bunch of images and we analyzed them, and then we put the results on GitHub. Different types of analysis, the code. And then in the paper, we said, okay, we'll go through this study that we did, but we'll also provide people with, code and images so that they can do stuff for themselves with it. So I like to do that because we're be open science type project. So that's something that's I think important too. Okay. Any other questions?
No, sir.
Okay. Well, thanks for meeting with me, and keep in touch, and look forward to seeing your contributions on Slack.
Yeah, sure, sir. Thank you.
Okay. Have a good day. Have a good week.